My today's class is independent events. In probability, so there is one of the topic is there, that is independent events. So first try to understand the definition of independent events. So we say events A and B are independent. So if probability of A intersection B is equal to probability of A into probability of B. So if this condition satisfied by two events A and B, so then we say the events A and B are independent events. So now consider some problems to check whether the given events are independent or not. So take some problems. If probability of A equal to 3 by 5 and probability of B equal to 1 by 5. Find probability of A intersection B. Find probability of A intersection B given that A and B are independent events. So here, given that A and B are independent events, so therefore, by definition of independent events, we can write probability of A intersection B is equal to probability of A into probability of B. So, probability of A 3 by 5 into probability of B 1 by 5. So, this is 3 by 25. The value of probability of A intersection B is equal to 3 by 25. Next problem. Let E and F be two events with probability of E is 3 by 5. Probability of F is 3 by 10 and probability of E intersection F 1 by 5. So, are E and F are independent events? The question is, are E and F are independent events? So, we know the definition of independent events. So, probability of E intersection F is equal to probability of E into probability of F. So, first multiply probability of E into probability of F. So, 3 by 5 into 3 by 10. So, this is 9 by 50. But probability of E intersection F is 1 by 5. So, but probability of E intersection F is equal to 1 by 5. So, which is not equal to, so probability of E into probability of F. So, the condition of two events are independent, then probability of E intersection F is equal to probability of E into probability of F. But here, these two are not equal. So, therefore, E and F are not independent events. Not independent events. Next problem. If A and B are independent events and probability of A equal to was 0.3 and probability of B equal to 0.4. So find question 1 probability of A intersection B. Second, probability of A union B. Third, conditional probability of event A given B as occur. Fourth, conditional probability of event B given A as occur. So here, given that A and B are independent events. So therefore, from the definition of independent events, probability of A intersection B, first one, is equal to probability of A into probability of B. So probability of A 0.3 into probability of 0.4. The product is 0.4. 1, 2. This is probability of A intersection P. Second, probability of A union B. So, we know the result. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection P. Substitute the values 0.3 plus 0.4 minus probability of A intersection P is 0.12. So this is 0.7, 0.12. So subtract 0.70, 0.12. So we get 0.58, 0.58. Probability of A and B is equal to 0.58. Next, third one. So conditional probability of event A given B has occurred. So we already know in conditional probability, this is equal to probability of A intersection B by probability of B. Probability of A intersection B 0.12 by probability of B 0.40. So this is divide, we get 0.3. Fourth one, conditional probability of B bar A. So the formula is, this can be written as probability of A intersection B by probability of A. So probability of A intersection B is 0.12 by probability of A is 0.4. So this is here probability of B, okay, probability of A is 0.3, not 0.4. So this is 0.4. So this is conditional probability of event B given A as occur. So in this way, we can easily find the required values. Next problem, given two independent events A and B such that probability of A is equal to 0.3, probability of B is 0.6, find probability of A and B, probability of A or B. So solution, probability of A and B, and means intersection. So probability of A and means intersection, probability of A intersection B is equal to, so since A and B are independent events, probability of A intersection B is equal to probability of A into probability of B from the definition of independent events. So probability of A 0.3 into probability of B 0.6, so 0.18. Probability of A and B or A intersection B 0.18. Next, probability of A or B. R means union. Probability of A or means union. Probability of A and B. So we know probability of A and B is equal to probability of A plus probability of B minus probability of A intersection B. So 0.3 plus 0.6 minus probability of A intersection B 0.18. So 0.90 minus 0.18. So after subtracting, we get 0.72. So probability of A or B or A and B is 0.72. Consider the next problem. If A and B are two events such that probability of A 1 by 4, probability of B 1 by 2, probability of A intersection B 1 by 8. Find probability of not A and not B. So here we can check probability of A intersection B is 1 by 8. The product of probability of A into probability of A into probability of B. So multiply these two, 1 by 4 into 1 by 2, this is 1 by 8, this is equal to probability of A intersection B. So therefore, probability of A intersection B is equal to probability of A into probability of B. Therefore, A and B are independent events. A and B are independent events. independent events. So, which implies when A and B are independent events, then A complement and B complement are also independent events. Are also independent events. So it is very important. So you have to find probability of not A and not B. So this is probability of not A means A complement of A and intersection, not B. So that is complement of B. So this can be written as probability of A complement intersection B complement. So this is here, since A and B are independent events, so A dash and A complement and B complement are also independent events. So therefore, probability of A complement intersection B complement is equal to probability of A complement into probability of B complement, because A complement and B complement are independent events. So therefore, we can write probability of A complement intersection B complement is equal to probability of A complement into probability of B complement. So probability of A complement is 1 minus probability of A into probability of B complement is 1 minus probability of B. So this is 1 minus probability of A 1 by 4 into 1 minus probability of B 1 by 2. So this is 1 minus 1 by 4 is 3 by 4 into 1 minus 1 by 2 is 1 by 2. So this is 3 by 8. Probability of not A and not B is 3 by 8.